Ever wondered why your favorite video games look so realistic? Or how massive AI models, like the ones that power self-driving cars or language models, actually get trained? The answer lies in a single piece of hardware, the GPU. The graphics processing unit is no longer just about making your games look pretty. Today, it's the engine behind some of the biggest breakthroughs in technology. Welcome to Unravel, Technology and Innovation. On this channel, we break down the complex world of tech, so you can understand how it all works, no matter your background. In this video, we're diving into the GPU, what it is, how it works, and why it's become the heart of gaming and AI processing. At its core, the GPU, or Graphics Processing Unit, is a specialized processor designed to handle graphics rendering. When you're playing a game, watching a video, or even just moving windows around on your desktop, the GPU is at work. Its job is to take data and turn it into images, animations, and visuals on your screen. But unlike the CPU, which is optimized for general-purpose tasks, the GPU is built for parallel processing, handling thousands of small calculations at once. This parallel design makes it not only perfect for graphics, but also incredibly powerful for tasks like AI training, scientific simulations, and cryptocurrency mining. Think of the CPU and GPU as two very different workers. The CPU is like a competent manager, smart, versatile, able to handle a wide range of tasks one after another. The GPU is like a massive team of interns, each one simple but together able to work on thousands of small tasks simultaneously. Where a CPU may have 8 or 16 powerful cores, a GPU can have thousands of smaller, efficient cores. This is what gives it the ability to process graphics in real time or train huge neural networks. The GPU breaks down complex problems into smaller pieces and solves them all at once. That's why modern GPUs are so effective at rendering millions of pixels per second or crunching through terabytes of data. The GPU's original and still most famous role is in gaming. When you load into a video game, the GPU is responsible for rendering 3D graphics, turning wireframe models into realistic scenes, applying textures and lighting, so objects look solid, shiny, or shadowed. Physics simulations, making water flow naturally or debris scatter realistically. Frames per second, FPS, determining how smooth your gameplay feels. The better the GPU, the higher the resolution and smoother the frame rates. This is why gamers chase after powerful graphics cards. They want the most immersive experience possible. And with modern technologies like ray tracing, GPUs can simulate realistic lighting, reflections, and shadows, bringing digital worlds closer to reality than ever before. But GPUs aren't just for games anymore. Their ability to handle massive parallel processing makes them the perfect tool for artificial intelligence. Training a neural network involves running billions or even trillions of mathematical operations. CPUs simply can't keep up. But GPUs can process all those operations at once, dramatically speeding up AI research and development. This is why GPUs are now used in deep learning and machine learning tasks, self-driving cars, where split-second visual recognition is crucial, medical research, like protein folding simulations, finance, where huge data sets need to be crunched instantly. In fact, many of today's breakthroughs in AI, voice recognition, computer vision, and language models wouldn't have been possible without GPUs. Not all GPUs are created equal. There are two main categories: integrated GPUs, built directly into the CPU or motherboard. Share system memory with the CPU. Weaker performance, but enough for browsing, video playback, or light gaming. Common in laptops and budget devices. Dedicated or discrete GPUs. Separate hardware, usually a powerful graphics card. Have their own dedicated memory, VRAM. Deliver vastly better performance for gaming, editing, and AI, found in desktops, workstations, and high-end laptops. Within dedicated GPUs, you also have divisions: consumer GPUs for gamers and everyday users, professional GPUs for AI researchers, 3D animators, and engineers. When you look at a graphics card, you'll see a flood of numbers. Here's what they really mean. VRAM, video. RAM. This is the GPU's memory. It stores textures, frame buffers, and other data needed for rendering images. More VRAM allows higher resolutions and more complex visuals. Cores, CUDA cores, stream processors. These are the tiny workers inside the GPU. More cores equals better parallel processing. Clock speed. Measured in megahertz or gigahertz, this determines how fast each core can operate. Ray tracing, a newer feature that simulates light in a physically accurate way, making reflections and shadows far more realistic. Power and cooling. GPUs are power-hungry and generate heat. High-end cards often need multiple fans, or even liquid cooling, to stay stable. As powerful as GPUs are, they aren't perfect. Cost. High-performance GPUs can cost as much as an entire computer. Power usage. They require significant energy, leading to higher electricity bills. Heat. Without proper cooling, they overheat. Availability. Demand from gamers, AI researchers, and even crypto miners has led to shortages. For many users, the challenge isn't just picking the right GPU, it's being able to buy one at all. So where are GPUs headed? AI acceleration. More GPUs now include specialized cores designed just for AI tasks, speeding up neural network training. Cloud GPUs. Instead of buying your own, you can rent GPU power through the cloud. This is already common in industries that need huge processing power but can't afford massive hardware. Efficiency improvements. Future GPUs aim to balance power with energy use, making them more sustainable. Real-time ray tracing and beyond, visuals will continue getting closer to photorealism. In short, GPUs are moving beyond just graphics. They're becoming the engines of modern computing. So, what is a GPU? It's the graphics processing unit, a processor designed for parallel tasks. It powers your games, fuels modern AI, and drives some of the most advanced technology we have today. If the CPU is the brain of your computer, the GPU is its creative heart, handling the visuals, the processing, and increasingly, the future of artificial intelligence. Next time you boot up a game, stream a movie, or read about AI breakthroughs, remember it's the GPU making it all possible. Got a question or topic you'd like unraveled next? Leave a comment below, and don't forget to subscribe. As we continue to explore the world of technology and innovation, one concept at a time.